Hello friends. Today we are going to study linear data structure that is stack. In the previous lecture we studied the linear data structures means the structures in which the elements are arranged in a sequence. So stack is an example of linear data structure. So let's start with the stacks. A stack is a list of elements in which an element may be inserted or deleted only at one end, called the top of the stack. Means in a stack we have a list of elements, and the elements are arranged in a manner in the stack that they can be inserted or deleted only from one end. If we take the example of a stack in real life, we can say we can see the stack of plates or the stack of books placed one upon other. So if we want to take any book or any plate from that stack, we have the option to take it from the top. So stack is an example of LIFO data structure, means last in first out. The one who comes at last will be the one who served first. So elements are removed from a stack in the reverse order of that in which they were inserted into the stack. So a stack is called a last in first out collection. This means that the things we have added or we have pushed into the stacks are the one that will get out first from the stack. It is a sequence of items that are accessible only only one end of the sequence. So we can say it can be work as a restriction on stack, that if you want to insert or if you want to pull out something from the stack, there is only one end from where you can insert or take out the data. So as I told you earlier, the real life example of stack can be a stack of plates. So you have seen in parties that plates are placed one upon another. So the plate that is on the top is the first one to be taken out, and it is the last one to be placed at the top, but it is the first one to be taken out. Same case is with the in the stack of books. Although we have the option that we can take out the plate or we can take out the book from the middle of the stack, but you can say it is a restriction on the stack that you can either you can place or you can pull out the data only from one end. So we can't take out the data, we can't take out anything from the middle of the stack. It's a restriction that if you want to insert something and you want to take out something from the stack, you have to start from only one end. So we have two operations on that can be performed on a stack, that is push and pop. Suppose this is a stack, if you and this is the one end from where you can insert or delete the data from the stack. The push is the operation that is used to insert the data into the stack, and pop is the operation that is used to take out the data from the stack. Here top is a variable that is indicating the element at the topmost position in the stack. Suppose this stack is full, then top is representing the location, the index of the topmost element. So push is used to insert items into the stack, pop is used to delete items from stack, and top represents the current location of data in stack. So top will get incremented or decremented as the data is inserted or deleted from the stack. For example, if we see it here, we have three elements in stack A, B, C. Then top will indicate the location, the index of this element C. When D is inserted, push D. When D is inserted, now push will now top will indicate the location of this D. When E is inserted, top will indicate this E. When we perform pop, Since pop, it means that we have deleted the topmost element of the stack. So whichever the topmost element in the stack, suppose here we have the topmost element E, then automatically E will get deleted. Now top will point to D. Again we perform pop operation. Now D will get deleted and top will point to C. So this is the procedure for stack. So we have an algorithm to insert an element in stack. Suppose we want to insert some element in stack. We have the stack. Top is representing the topmost position of the element. Max is the total size of the stack and item that you want to insert in the stack. So if top is equal to maximum stack, means if the value of top is equal to the size of the stack, then print overflow. What do you mean by overflow? Overflow is a condition when you try, is a situation when you try to insert an element into the stack, but the stack is full, there is no space available in the stack, then we say that the stack is overflowed. So then in that case we can't insert the element into the stack. Otherwise, if top is not pointing to the topmost element, if top is not equal to the size of the stack, in that case we can increment the counter variable top to +1, and now top will point to the next position and we will assign the item to that position. In this example, suppose here the position of top is 6 and we want to push D into this stack. Then the position of top will equal to, if we start the counter from 1, 2, 3, then we will increment the counter top equal to top +1, that is 4, and then stack 4 is equal to item. Now top is pointing to this data item D. So if you want to delete an element from the stack, that operation is called pop. So here stack, from where you want to delete the data item, top is indicating the position of the topmost element in the stack, the item you want to get deleted from the stack. Okay, so if top is equal to 0, means if there are no elements present in the stack, in that case you can't delete anything from the stack since the stack is empty, and that condition is called underflow. If no elements are present in the stack, then that condition is called underflow and you will return. Otherwise, if the stack is not empty, this condition is false, then you take the topmost element into the variable item, okay, and you can decrease the counter by 1. So here top is indicating to the position of E. So if you perform top operation, then the counter of top will get decremented by 1, that is now top will point out to D and E can be taken out. So the algorithm stops over here. So let's take another example. Suppose in this case we have the stack empty. We push an element 2, now top will point to the position of 2. Again push 5, now top will point to 5. Push 7, then top again incremented by 1 and top will point out to 7. Push 1, then again top will point out to 1 and it will get incremented by 1. Now we perform pop. Now if we are performing pop, that means the element from the topmost position in the stack will get deleted. So since this one is the last element to enter in the stack, so this one will be the first element to be taken out from the stack, since we have only one end from where we can insert or we can delete the element according to the property of last in first out, LIFO. So the topmost element that will get deleted is 1. So now top will get decremented by 1 and it will point out to 7. Again we push 21, again 21 will come up over 7. Now top will again incremented by 1, top will point to 21. Again we perform pop operation. So 21 is the last element that has been inserted into the stack. So we this one is the first one to be taken out of the stack. Again we perform pop operation. So 21 is the one that comes out from the stack, and top will get decremented by 1. Again we perform pop operation, then 7 will get out and top will decremented by 1. Again if we perform pop operation, then 5 will come out and top will point to 2. So this is the whole procedure how push and pop operations are performed in a stack. So if we talk about the applications of stack, the first application is recursion. So you have studied in a C language that recursion is the process in which a function calls itself. So if you studied recursively, so if you have studied C language, you see the example of factorial of Fibonacci series. So in factorial the function calls itself recursively. So the function that is called in the last is the first one to return the result, and then that result will get recursively get added into the previous functions. So recursion is the example of last in first out, means the example of stacks. Second, we can convert infix expressions into postfix expression. In the further lectures we will study about these expressions, the postfix expression, the infix expression. These are also the examples of stacks. Backtracking problem. Backtracking problem is, suppose you want to go from one place to another, landmark 1 to landmark 2. So you follow some route. So it is possible that from returning from landmark 2 to landmark 1 you also follow the same route. So the area that you covered in the return journey is the area that you visit first. So backtracking is also an example of stack. So converting a decimal number into a binary equivalent is also an example of a stack application. So thank you for now.